Imagine the year 2050. The global population has swelled to nearly 10 billion people, and two-thirds of us are living in dense urban centers surrounded by concrete, glass, and steel. Now ask yourself, where is the dinner on your table coming from? Right now, our food system is stretched thin, relying on vast amounts of arable land that is rapidly degrading, and a transportation network that ships produce thousands of miles before it reaches your plate. We are running out of horizontal space, but as architects, when we run out of space on the ground, we look up. What if the skyscraper of the future wasn't just housing or offices? What if our buildings could feed us? Today, we are looking at one of the most provocative shifts in urban design history, the rise of the vertical farming city. Hi, I'm Maria, an architectural designer and founder of Bogat Architecture and Design, and today we'll explore vertical farming cities feeding future generations. So, to understand why this architectural typology is so critical, we first have to look at the flaw in our current urban design. For the last centuries, city planning has been defined by separation. We have residential zones, commercial zones, and industrial zones. Agriculture was pushed far to the periphery, out of sight and out of mind. This separation has created a massive logistical burden. The average head of lettuce in the United States travels 1,500 miles to get to the consumer. That is a tremendous amount of fossil fuel, packaging waste, and spoilage. From a design perspective, our cities are consumers. They devour resources like food, water, energy, and they export waste. They are linear systems. The concept of vertical farming is an attempt to turn the city into a circular system, something that acts more like an ecosystem. We call this agritecture, the seamless fusion of agriculture and architecture. It's not just about putting a few tomato plants on a balcony. It's about integrating high-yield, industrial-scale food production into the structural DNA of our high-rises. It challenges us to rethink the purpose of the building envelope and the mechanical heart of our structures. But before we talk about the building itself, we have to understand the technology inside, because form follows function. If we are designing a vertical farm, we aren't using dirt. Soil is incredibly heavy. Saturated soil can weigh from 100 to 120 pounds per cubic foot. If you tried to fill a 40-story skyscraper with 3 feet of topsoil on every floor, the structural requirements would make the project financially impossible. Instead, we rely on 3 main methods, each dictating a different architectural approach. First, there's hydroponic. This is growing plants in nutrient-rich water. From a design standpoint, this means the building becomes a massive plumbing system. We're dealing with pipes, reservoirs, and pumps on every level. Second is aeroponic. This involves misting the roots of plants suspended in air. It uses 95% less water than traditional farming, which significantly reduces the dead load on the building structure. However, it requires sophisticated humidity control systems. Third is aquaponics, a symbiotic system where fish produce waste that feeds the plants, and plants clean the water for the fish. This creates a live load issue. Water tanks are heavy and they move, so you need reinforced concrete slabs and careful distribution of weight. Now let's put on our architect hats. The biggest challenge in designing a vertical farm isn't the water, it's the light. In traditional field, the sun does all the work for free. In a skyscraper, we have a geometry problem. Most commercial towers have deep floor plates. The distance from the window to the core might be 30 to 40 feet. Natural light only penetrates about 15 feet into the building effectively. If we rely solely on glazing, glass facades, only the crops on the perimeter will grow, and the crops near the elevator core will die. So we have 2 architectural solutions here. The first solution is to change the shape of the building. We can design narrow towers or towers with high surface area to volume ratios. Think of shapes like a thin rectangle, a cylinder, or even a cross shape. it maximizes natural light penetration. The second solution, and the most common one currently, is a closed system relying on artificial lighting where we use LED spectrums, pinks and purples that target the exact photosynthetic needs of the plants. This changes the building envelope entirely. If we use LEDs, we don't need windows. In fact, windows might be a liability because they let heat in or out. A vertical farm relying on LEDs might look more like a brutalist monolith or an opaque insulated box rather than a glittering glass tower. Now let's talk about the invisible architecture, the HVAC systems, heating, ventilation, and air conditioning. In a standard office building, we are managing the heat generated by human bodies and computers. In a vertical farm, we are managing transportation. Plants release moisture vapor. A dense indoor farm is essentially a jungle. It wants to be 100% humid. But high humidity breeds mold and structural rot. It can corrode steel connections and damage concrete over time. So the mechanical engineer and the architect have to design massive dehumidification systems. This actually presents a unique opportunity for energy recycling. When you condense water vapor out of the air, you recapture heat. The heat can be used to warm the building in winter or even be pumped to adjacent residential towers in a mixed-use district. The building becomes a thermal battery. I mentioned weight earlier, but let's dive deeper into the structural engineering. A standard office building is designed for a live load of about 50 to 100 pounds per square foot. This accounts for desks, people, and partitions. A vertical farm, even the one that is using aeroponics, has a much higher load density. If you have racking systems that might go 20 feet high on a single floor, we have water tanks, you have harvesting robots. That means that we have beefier columns and thicker floor slabs. This increases the embodied carbon of the building, the amount of concrete and steel we use to build it. This creates a tension. We are building an eco-friendly farm, but we are using carbon-intensive materials to support it. So to solve this, architects are using timber. Mass timber or cross-laminated timber is strong, lightweight, and carbon sequestering. A mass timber vertical farm would be the ultimate expression of sustainability, a building made of plants, growing plants. So is the future of tower that is 100% farm? Probably not. The economics are difficult. Real estate in cities like New York, London, or Tokyo are expensive. That is cheap. So if you build a skyscraper on a plot of land worth 50 million, you cannot pay the mortgage by selling basil. This is where the mixed-use typology comes in. This is the sweet spot for architects. Imagine a 60-story tower. The bottom floors, which are shaded by neighboring buildings and have low rental value, are dedicated to vertical farming. The middle floors are offices. The top floors, with the best views and light, are residential luxury apartments. In this scenario, the farm acts as a utility for the building. It provides fresh food for the residents, which is a premium amenity. It filters the air for the offices, and the gray water from the apartments, like showers and sinks, is treated to use to water the crops. This is architectural symbiosis. The building functions as a closed loop. The waste of one tenant becomes the resource of another. Another fascinating design direction is the productive facade. Instead of hiding the farm tank inside, we wear it on the outside. We've seen this with Stefano Boeri vertical forest in Milan. While the project focuses on trees for biodiversity and shade, the principle can be adapted for food. Imagine double skin facades, 2 layers of glass with a walkway in between. In that thermal buffer zone, we can grow crops. This acts as insulation for the building, reducing heating and cooling costs while producing food. It transforms the visual identity of the skyscraper. Instead of a static gray skyline, we get a living, changing green skyline that shifts with the seasons. However, this comes with maintenance challenges. You need window washing units that are actually harvesting units. You need to ensure high winds at 500 feet in the air don't strip the crops. It requires aerodynamics modeling to ensure the plants can survive the microclimate of the upper atmosphere. Now let's look at where this is actually happening. Singapore is the current world leader in this space. They are an island nation with very little land, so they have developed SkyGreens, a low-carbon hydraulic rotating system, which is basically an A-frame structure that rotates through of plants. And as they move up, they get sunlight. As they move down, they get watered. The other side of the spectrum, we have aerofarms in Newark, New Jersey. This isn't a skyscraper, it's adaptive reuse. They took an old steel mill and converted it into the world's largest vertical farm. This is perhaps the most sustainable approach, retrofitting existing abandoned industrial stock. As architects, we love adaptive reuse. It revitalizes blighted neighborhoods without the carbon costs of new construction. It turns a Rust Belt relic into a futuristic food hub. But beyond the engineering and the economics, we have to talk about the human experience. Biophilia is the hypothesis that humans have an innate tendency to seek connections with nature. We feel better when we are around plants. Our cortisol levels drop, our productivity increases, and our mental health improves. Bringing farming into the city isn't just about calories. It's about reconnecting urbanities with the biological process. Now imagine a residential tower where the lobby isn't just a marble desk, but a hydroponic garden where you pick your salad for dinner. Imagine schools located inside vertical farms where children learn biology not from a textbook, but by managing a crop cycle. It softens the harshness of the urban environment. It reintroduces seasonality to a city life that often feels disconnected from time. Now, of course, I don't want to paint a utopian picture without addressing the hurdles. The biggest barrier remains energy. Even with efficient LEDs, replacing the sun is expensive. Depending on the local energy grid, a vertical farm could actually have a higher carbon footprint than a traditional farm if the electricity is coming from coal or gas. For vertical farming to be truly sustainable, it must be paired with renewable energy, solar, wind, or nuclear. There is also the issue of crop variety. Right now, vertical farming is great for leafy greens, herbs, and microgreens. It's not currently viable for calorie-dense staples like wheat, corn, rice, or potatoes. You need too much space and too much time for those crops. So vertical farming won't replace traditional agriculture entirely. They will supplement it. Forward, the vertical farm will likely become a node in the smart city network. Imagine sensors in the farm communicating with the city's power grid, turning on the lights only when the energy demand in the city is low to balance the load. Imagine autonomous drones delivering the harvest from the farm scraper directly to the balconies of apartments within a 5-mile radius. The role of the architect here is to design flexibility. We need to create long-life, loose-fit buildings, structures that are robust enough to handle the load of the farm today, but flexible enough to be converted into housing or offices 50 years from now if the technology changes. Vertical farming cities represent a fundamental shift in our relationship with the built environment. For thousands of years, we built walls to keep nature out. Now we are designing structures to invite nature in. It is a typology that demands collaboration between architects, botanists, engineers, and data scientists. It asks us to view the city not just as a place to live, but as a living thing itself, an organism that consumes, metabolizes, and produces. As we face the challenges of the coming decades, these productive towers might just be the key to resilience, ensuring that no matter how dense our cities became, we are never too far from the source of our substance. So if you enjoyed this video, make sure to like and subscribe for more content like this. I'd love to hear your thoughts in the comments. Would you live in a building that grows its own food? Until next time.